Welcome to CodeEnv. In this course, we will be looking at the command line. The command line is a text-based program that allows you to interact with your system. Learning the command line involves learning how to use different commands and understanding their output. To give you an overview of what we'll be learning, we'll start by learning how to navigate our way around the file tree using full and relative paths. We will learn different file and folder operations like creating, copying, deleting, moving, and renaming. We'll look at file permissions and change permissions on files and folders. We'll also cover how to work with archives and zip files. We'll pick up some useful tools like finding files, searching through them, and piping commands together to build a better search utility. We'll cover text files, how to create and edit them using VI Text Editor. We'll cover environment variables and how to view and set them. Finally, we'll look at monitoring our system. We'll learn how to monitor the memory, processor, and disk space. We will also look at finding information about running processes. It's going to be a fun-packed course, so let's get started. Let's start by learning how to navigate the file tree. The file tree is the hierarchy of folders and files on your system. At the start of every journey, it's good to know where we are. To find out our current location, we can use the pwd command. Pwd will display the full path to the directory we're in. Next, let's list the files and folders in our directory. Use the ls command to list the contents. Now, let's try ls-l. Most commands used in the command line accept different options. Options are usually supplied through single-letter parameters written with a preceding minus. Options can be placed together using a single minus sign and multiple letters with no spaces. By adding a few options to the ls command, we can get a lot more information about the file list. The L option shows the files in the list with the following information. Reading the columns from left to right, you have the file permissions, the number of links, the owner's name, the owner's group's name, and the number of bytes in the file. The next three columns show the date and time of the last modification, and the final column is your path name. In Unix systems, hidden files start with a dot. To view these files, we need to use the A option. A stands for all. Try ls-a and see what extra files you get. A handy command to list all files and folders in the order of last modified is ls-latr, which can be pronounced ls-later. The T option lists results in modified time order, and the R option reverses the order to show the last modified at the bottom of the list. Great! Now that we know where we are and what's around us, let's learn how to move around the file tree. To change directory, use the cd command. With cd, you can either provide a full path or a relative path. The full path is the path that starts from your root directory. The root directory is the top folder of your system. Relative paths, on the other hand, start from where you are. When working with relative paths, a single dot represents the folder you're in, and two dots represent the parent directory. So, if you want to move one directory up, you can type cd ... To move two directories up, you can type cd ... /.. Let's change our directory to enter the folder artwork and list contents of this directory. You can follow along by typing these commands. Can you now change directory to go to the Flasker folder, which is under the sibling folder examples? I'm going to pause here for you to try it out. So play the video to see the answer. In this part, we're going to perform some file operations. We'll learn how to create, copy, move, rename, and delete files and folders. Let's start by going back to the var code directory. You can do this by running cd, then the full path, /var/code. To create a new folder, we use the mkdir command, which stands for make directory. So type mkdir space experiments. Next, we want to copy the file tox.ini into our new directory. We use the cp command here. Type cp tox.ini, which is what we want to copy. Then type space and the name of the destination folder, experiments. You can now list the files under the experiments folder to make sure it got copied correctly. This is fine for files. However, if we want to copy folders from one place to another, we need to copy the folder and all its contents. To do that, we pass the R option to the copy command. R stands for recursive and tells CP to copy the folder and keep recursing down its contents. Let's also copy the tests folder under the experiments folder. So you can type cp-r tests space experiments. Moving files and folders works exactly like copying, except that we use the mv command. We also don't need to recurse the directory when moving folders. Try moving the README file to our experiments folder. Now, try moving the docs folder. Play the video to see the answer. Let's move on to renaming. There isn't a command for renaming files and folders. All you need to do is move them to the new name. So, if we want to rename the file authors to flask_authors, just use the mv command and pass in authors and flask_authors. You can do the same with folders. Finally, let's look at deleting. To delete a file or folder, you need to use the rm command. rm stands for remove. Let's delete the file tox.ini from our experiments folder. Type rm, then the relative path to tox.ini. To delete folders, we need to use the R option. In this section, we'll look at file permissions. By the end of this, you should be able to read and set permissions on files and folders. Permissions dictate who can view, amend, and execute files. To view the permissions of a file, we use the ls-l command. Try viewing the permissions of the changes file. In the first column, you see the permissions, so let's look at this in more detail. The permissions column is a set of 10 characters. Ignore the first character, and let's look at the remaining 9. The 9 characters are split into 3 parts. The first of the triads relate to the owner's permissions. The next triad relates to the group's permissions. And the final triad relates to everyone else. In each triad, each character of the triad relates to a different operation. The first character relates to reading, the second relates to writing, and the third relates to executing. If the entity doesn't have a certain permission, you will see a dash instead of the letter. Coming back to our example, we can see that the user has read and write permissions, whereas the group and the rest of the users only have read permissions. To set permissions on a file, we use the chmod command. Chmod takes the permissions as the first parameter and the file as the second. Permissions can be defined using 3 number digits, where the 3 numbers define the permissions for the user, the group, and all in that order. A more intuitive way is to use the declarative method. In the declarative method, we define the entities we want to change, then the operator, and finally the permission. Let's look at an example. Here we are adding write permissions to the user. The letter U defines the user entity, the plus sign indicates an add operation, and the W indicates a write permission. If we want to add read, write, and execute for everyone, we use the following, where we define the entity's user, group, and all. We use the equals sign to indicate we are setting, and we define all the permissions, read, write, and execute. You can, in the same way, use the minus sign to remove permissions. Finally, if we want to change the permissions for all the files under the folder, let's say we want to add read permission for all the experiments folder. We need to use the R option to recurse the tree. R is capitalized here. Try adding write access for everyone, for all the files under the artwork folder. Play the video to see the answer. The answer is the following command. When working with command line, you sometimes need to move files on and off servers, or you need to install packages that you downloaded. In most of these cases, you will need to deal with archives and zips. Here, we will work with the most popular archiving tool, the tarball, and look at the gzip command for zipping. To be able to zip a folder and compress it, we need to first convert the folder into a single file. This is where tarballs come into action. Tarballs are archives of files and folders bunched into one file. The extension for tarballs is .tar. Let's create a tarball from the tests folder. To do this, we issue the tar command, followed by the option cf. We then specify the name of our new tar file. Remember to add .tar. Finally, the name of the files and folders we want to include. To unpack a tar, we use the X option instead of C. To unpack the tests.tar file, we issue the following command. If you want to see what the command is doing, you can add the V option for verbose logs. Now that we created our tar, we want to compress it. For this, we use the gzip command. You can gzip any file you want by passing it through the gzip command. The file outputted will have the extension .gz. Before we compress tests.tar, let's have a look at the file size. We can do this using ls-l. Now, gzip tests.tar and check the size again. This time add .gz to the file name when you run ls. To uncompress a file, you need to issue thegunzip command. It works the same way as gzip. In many cases, you need to search and find files on your system. In the command line, we don't have the luxury of a UI search utility. However, we do have the find command. Find will return a list of file paths with the pattern you're looking for. So, to find all the Python files under var code, you can issue a find for all files ending with .py. We write this command as find, then path in which we want to look. We then pass the name option and type the pattern to look for, star.py. The star here indicates that we want to match any file names that end with .py. Can you do the same to find all test files under var code? Remember, text files usually end with .txt. Play the video to see the answer. Now that we can find files, how about we try to search them? Let's say you want to look through a file and find all occurrences of the string def test. To do this, we use the grep command. Let's grep the file test basic.py under the tests folder for the phrase def test and see what we get. One thing to bear in mind is that grep is case sensitive. If you want to search ignoring the case, use the I option. This brings us into the next section, and we ask, how can we search a directory and display all the files that contain a piece of text? With Unix commands, you can chain multiple commands together using the pipe symbol. For example, when we use the find command, we get a list of paths back. We can pipe this list into the grep command one line at a time. To do this, we first write the find command, then we use the pipe symbol. Now the pipe symbol will pipe the output as a whole, whereas we want to pipe each line. To do this, we use the xargs command, followed by -i and curly brackets. This part splits find into separate lines. We then run grep on our string and curly brackets again, symbolizing the file paths. We pass the h and n options to grep display and file names and line numbers. The output of grep is quite large, and we need to have a more convenient way to look at the results. We can pipe the output a second time into the less command, which gives a better view of the results. In less, you can use the arrow keys to scroll up and down. To quit less, press Q. As a little exercise, try piping grep into WC or word count command and see what you get back. You can run WC with the L option to get the number of lines returned. We had a quick look at the less command when piping large output. The less command can also take a file path as parameter to display a read-only view of it. For writing text files, Unix systems provide a number of tools, and which one you use really depends on personal preference. In this course, we will look at the VI editor. To start the VI editor, use the VI command. You can supply a file path you want to read or a new file name to create a new file. Let's open the changes file. The VI editor starts in read mode. To enter the write mode, type I for insert. You can then move freely around, changing the text. To exit write mode, press escape. The VI editor works through key commands, so beware of what you press when you are in read mode. To save the file, type :W! To exit the editor, type :Q! One important part of working with Unix systems is reading and setting environment variables. Environment variables are used by the system and applications to manage their behavior. Environment variables are most useful when you want your application to be flexible and to be able to change paths and behavior without having to change the code. By convention, environment variables are written in uppercase. To reference an environment variable, we use the $ symbol, then the variable name. To view a variable, we use the echo command. Let's look at one of the system variables, shell, which defines the system shell. To view the shell, we type echo $shell. To set an environment variable, we use the export command. So to set a new variable, called myPath, we issue export myPath equals varcode. Now we have a new environment variable, myPath, which points to varcode. In the final part of this course, we'll have a look at some commands for system monitoring. These commands form a handy toolkit to manage your system. To start, let's have a look at our disk space. Run the command df-h. This will display all the disks installed on your system and show you the capacity of each. The H option displays the results in a human-readable format. Next, let's have a look at our memory usage. To do this, we can use the top command. Top displays all the processes running and also shows us how much memory and CPU is being used in total and by each process. You can exit top by pressing Q. To get a list of processes running on your system, we use the PS command. Adding the E parameter includes other users' processes, and F displays the parent process, IDs, and the user name. Try running the PS commands and piping it into the grep to find all Python processes. Press play to see the answer. To kill a running process, you need to issue the kill command with -9. The 9 indicates the type of signal you're sending, which in this case is a kill signal. I hope you enjoyed this course and learned your way around the basics of the command line. I want to leave you with one last command, which is man. Man displays the manual for any command you want to learn more about. Just type man and the command after it to display the manual for that command. Until the next hands-on CodeEnv course, take care.